Hi, I'm gonna talk about El Nino. What is El Nino? El Nino is climate cycle in Pacific Ocean with global impact on weather. These unusually changes of climate happen on late of December. The data is expected to aid in the understanding and prediction of El Nino Southern Oscillation cycles. The learning process that we use in this project is we import the dataset from kaggle.com and save in CSV file form. Then we deal with the missing value in dataset using mean substitution. Then we import the data into R, build the clustering model using FCM and HCM, evaluate and compare the accuracy between both models, analysis the clustering result with the real data, and making conclusion on clustering. There are 178,080 of dataset. However, we only analyze 1,411 from year 1980 until 1985, where in 1982 and 83 there are strongest El Nino occur. The attribute that we use are date, meridional wind, air temperature, and sea temperature.
On how to implement the fuzzy C-mean. First, we have to do the mean substitution to replace the missing value on the dataset. After that, we need to install and load the package into the R and load the dataset in the form of CSV. To run the FCM, we have to initialize all the dataset. We have to specify the number of clusters to initialize the algorithm. For FCM, we have used Euclidean distance metric to compute the distance between the cluster center and the object. To visualize the result, we have used pairwise scatter to display the features, and to display the result, we use cluster plot with f-width cluster. In order to validate the result, we use the root mean square deviation and also mean absolute deviation to find the accuracy of the cluster.
For the implementation of HCM, first we prepare the data by remove or estimate the missing data or rescale the variable of comparability. Next, we can determine the appropriate number of clusters by plotting of the within group of sum square, but we can still determine our cluster number by ourselves. Okay, next we can plot the cluster by using k-mean, bracket my data, so, comma 3 is the number cluster that we use to fit, and use the library cluster and cluster plot to show the data. Okay, to find the accuracy, we can calculate the root mean square deviation RMSD and the sum of square for the total SS and overall SS. Okay, the result for fuzzy C-mean is RMSD is 2.94712 and the mean absolute deviation MAD is 19.31433. Okay, for the sum of square for fuzzy C-mean is 69.8%. Okay, for the result for hard C-mean, we can get the root mean square deviation is 6.73888171 and the sum of square is 61.22%. Okay, for the result, we get that FCM is better because it's more accurate and clustering group are more separated from each other.
Next, we analyze the clustering result for using FCM with the real data using U and I. This is as we can see in the graph from 1983 is the highest level of El Nino. So we conclude that cluster 2 is the strongest strength of El Nino, and from 1980 to 1981 is the intermediate level. So we can say that cluster 3 is the intermediate level of El Nino, and lastly is from 1984 to 1985, which indicate the cluster 1 which means the cluster 1 is the weakest strength of El Nino, in which at this level La Nina happens. And this one we analyze the El Nino in 1983 by month, and we can see the cluster 1 and cluster 2 is the strong El Nino based on the graph. And we can say that the cluster 3 is the weakest strength, indicate the weakest strength of El Nino. And from this analysis, we can say that fuzzy C-mean can perform the clustering better than HCM.